Exercise set 2-4, Evaluating Simple Arguments that Use Numbers, from a Workbook for Arguments by Morrow and Weston. The objective of this exercise set is to develop a critical eye for arguments using simple statistics. A few tips for success. Many misleading uses of statistics can be detected with 3 simple questions. What exactly are these statistics saying? Are these statistics believable? And do these statistics really show what the argument claims they show? Be sure to ask yourself each of these questions when evaluating the following arguments or any argument that uses statistics. In addition, Rule 10 introduces some specific pitfalls in arguments that use simple statistics. Rates or percentages offered without relevant background information. Statistics, often surprisingly precise, that no one's likely to know with any confidence. And results of manipulative surveys or opinion polls. Thoughtless extrapolations. The sloppy use of numbers to try to justify conclusions that the statistics just don't support. It's important to look out for all of these pitfalls in the arguments below. Whereas Rule 9 urged you to include background rates when giving examples, the use of rates or percentages without background information is just as problematic. If you see an argument that only gives rates or percentages, ask yourself whether those rates might be misleading. Do you know enough background information to figure out whether, say, 10% decline is significant? If not, the argument's author may be trying to mislead you into thinking that something is a big deal, even when it's not. Another question to ask yourself when dealing with statistics is how someone would know or could have learned that particular statistic, and how reliable that method is. Suppose you're told that 68% of people floss daily. How would anyone know that? Most likely, a pollster asks people whether they floss daily. People sometimes lie. Or let's just say they sometimes shade the truth for pollsters. Though, especially when they're embarrassed about the true answer, they don't quite want to face it themselves, or otherwise fear that their true answer is not socially desirable. So, the figure that 68% of people floss daily might overestimate the percentage of people who floss daily. In general, the harder it would be to figure out a statistic, the more skeptical you should be that a statistic is accurate. But don't go overboard with this either. Statisticians have developed very clever techniques to get around these kinds of problems. You'll need to consider whether a particular argument was written by someone with the ability and motivation to use those techniques. Even with statistics that could be determined with some accuracy, some organizations might be more interested in getting a particular result than learning the truth. Pollsters can skew the results by using biased samples or asking loaded questions. Running tests over and over again until you get the desired results is another way to manipulate statistics. A toothpaste company can keep asking groups of 10 dentists which toothpaste they recommend until they find a group where 9 out of 10 recommend the company's brand. Pretty good trick, huh? If a statistic comes from a source that's more interested in getting their preferred result than in getting the truth, you should be skeptical of the statistic. Each of the following arguments use numbers in a misleading way. Explain why each argument's use of numbers does not adequately support the argument's conclusion. All right, here's the sample. According to U.S. News and World Report's compilation of statistics provided by law schools, 93% of law school graduates have a job 9 months after finishing law school. That's up nearly 10 percentage points from 1997, when law schools reported an average employment rate of 84%. The employment picture for law school graduates is better than ever. So here's a possible way to respond to this, identifying some problems. This argument cites 2 employment rates for recent law school graduates to show that the employment picture for law school graduates is better than ever. There are several reasons to be skeptical of this argument. First of all, it's worth noting that these statistics come from the law schools themselves, who have an incentive to inflate employment rates. Second, the argument doesn't specify that 93% of graduates are employed as lawyers, which is what we really want to know about. It could be that half are employed as lawyers and 43% are flipping burgers and making cappuccinos. Third, the argument claims that the employment picture is better than ever, but it offers only one point of comparison, 1997. It could be that 1997 was a particularly bad year for law school graduates. We'd need more background information to evaluate the relevance of that statistic. Here's another example from number 1. A burglary occurs every 15 seconds in the United States. Up to 80% of forced entries occur through a front door or window. That's why it's essential to invest in a product like On Guard security door brace, which helps prevent would-be burglars from breaking through your front door. Now, here's a way we might respond identifying some problems with this argument. This argument tries to convince you to buy a security door brace by claiming that up to 80% of forced entries occur through a front door or window. This is misleading for many reasons. First, why does it say up to 80%? Does this mean that as a national average, nearly 80% of forced entries occur through the front door or window? Or does it mean something less impressive? Also, the statistic mentions only forced entries. How many burglaries result from forced entries as opposed to other methods of entry? And notice that the statistic is for entries through a front door or window. What share of these forced entries occur through a window, for which a security door brace wouldn't even help? All right, question 5. Environmentalists warn that humans' carbon dioxide emissions are endangering the planet, but the Earth naturally emits far more carbon dioxide than we do. In fact, humans' cumulative carbon dioxide emissions over the whole human history are just 0.0022% of the total amount that has been emitted by volcanoes over geological history. Given that our emissions are such a teeny fraction of natural emissions, there's no need to worry that our emissions will change the climate. All right, here's our response, identifying some problems. This argument compares humans' cumulative carbon dioxide emission to the cumulative emissions from volcanoes over all of geographical history. It notes that our emissions are teeny in comparison to those volcanic emissions, less than 0.001%. This is misleading because it's comparing human emissions over, say, 10,000 years to natural emissions over 4.5 billion years. Furthermore, the argument gives no reason to think that this comparison is relevant. Why would it even matter how humans' emissions stack up against all the volcanic emissions in geological history? All right, the final example. During a typical week, the average person lies to 34% of the people whom he or she encounters during that week. This includes both altruistic lies, i.e. lies told to avoid hurting someone's feelings, and selfish lies, for example, lies told to gain some advantage, as well as lies to both close friends and casual acquaintances. Clearly, you can't believe much of anything that anyone says. So, a few problems with this argument. The conclusion of this argument is that we can't believe much of what anyone says. In other words, it's about the percentage of statements that are true. The premise, though, is about the percentage of people to whom the average person lies. Since the conclusion and the allegedly relevant statistics are about different things, the statistic doesn't support the conclusion. To see why, suppose that I say 100 things to each of 100 people during the week, for a total of 10,000 statements. If I tell one lie to a third of these people, I've lied to nearly 34% of the people, but only 33 out of 10,000 statements, a third of 1%, were lies.